Hello and welcome back to another LeetCode video. Today we're looking at LeetCode 3407, substring pattern match, substring matching pattern, that way around. And it's an easy problem, and we're going to use it to practice interviewing, which means we're going to practice a systematic approach. And easy problems help with that because it prevents us getting lost into trying to solve a difficult problem, so that we can focus on the interview process and communications and expressing clearly what we're trying to do. And if you've seen my other videos, you know this is kind of what this is about. It's really just about practicing the interview process, and I'm doing that and just recording it. So yeah, step one, let's understand the problem and see what we are dealing with here. So we are given a string S and a pattern string P, where P contains exactly one star character. If the star in P can be replaced, or the star in P can be replaced with any sequence of 0 or more characters. Return true if P can made a string of S, and false otherwise. Interesting. So this is like a regular expression matching pattern thing light, I would say. Now what I would ask interviewers, what does the input exactly look like? And the output, should it just be true or false, or should I return maybe a numerical value? Can the strings be empty? Is the length guaranteed to be greater than 0? And are there any limits to the length of the strings? Because that's going to be important information for our, for our time and space complexity analysis, right? We'll have to do that. Just going to write that as placeholder space. And on LeetCode, well, the constraints are given always here, so we just read them. So we can see the strings have at least one character. We're going to ignore the upper bound, otherwise everything is automatically constant space and constant time when we do our complexity analysis. And S contains only lowercase English letters, so that's also an important information. When you're given strings, always ask, what characters can be in the strings. And P contains only lowercase letters and exactly one star, right? Cool. So the next step after understanding the input and the outputs and what the problem is come up with some problems or some examples, either on your own or you can ask the interviewer, do you have an example for me that I can use to go through? Otherwise, make up your own. Now here on LeetCode, we're given one. So here the input string is LeetCode and the input pattern is EE star E, right? And the output is true simply because, why is it? By replacing the star with TCOD, the substring LeetCode matches the pattern. So the goal is really just to check if the pattern is a substring of the input string S. So that's the key problem. Okay. Second example. So we have the string car and we have that pattern C star V. Obviously V is not in S, so it can never be a substring, right? Regardless of what we put in place of the star. We could put an A, but we still have no match because of the V. So in this case, I would say, So in the first example, we can see that EE is part of the string S, and E is also part of the string S at a later position than EE. And that means everything that is in between can be matched with our star. So maybe that's the first insight that we have by going through the examples. And this is really why you go through the examples. You try to get some insights. So I would say, yeah, if we search for EE, so for the first part of the pattern, we find it, and then we find E sometime later, then the answer is always going to be true, right? Because we can turn P into a substring of S. Now here in this example, if we try to find C, we find it in car, but then if we try to find V, we don't find it. So that means we can't turn the pattern into a substring of S. So let's try our approach now with the third example. So we have luck and the pattern is U star. So we find the U, and there's nothing behind the star that we need to match. So that's an automatic true as well. So if only I would say, we could call the part before the star maybe the prefix of the pattern, and the part that comes after the star, the postfix of the pattern. So if we split up P into prefix, postfix, then we perform the search for the prefix and for the postfix. Then we would have to consider the case where the postfix or maybe the prefix is empty. Right? So if the prefix or the postfix is empty, we need to only find either one of them. And if both are empty, it's always true because we can make pattern equal to S. All right, so I think that was super useful. So going through the examples actually gave me a very good idea of how I could solve this problem. So, and yeah, and I would now suggest interview. So I would just split up the string P into prefix and postfix, and then try to find the prefix, try to find the postfix, and yeah, return, true, like I explained before. If P can be turned into a substring of S, otherwise false. And then I would ask the interviewer if that's fine for me to implement that, and then the interviewer would say yes or maybe, would ask me, okay, what's the time and space complexity of that? Well, searching for a string is always going to be, well, if you use Python built-in function, it's going to be off, I guess. I think there's a linear time algorithm for that. Or that is linear in the input and search string. So I think it would be linear in the length of the two strings. So let's say n is length of S plus length of P. Then it's linear time. And we have to store a prefix and a postfix, so that's also same space. So linear time and space, where n is the length of our two strings combined. That's what I would say. And then, yeah, can I implement this? Yes, you can, sir. Oh, I'd say awesome. Okay, now I'm going to implement this. I'm going to implement the splitting of the pattern string. And, well, we just split it by the star. And just double check if P is always in there. Exactly one. Contains only lowercase letters and exactly one star. So that means our split is always going to work. Now, prefix and postfix could be empty, right? So if not prefix and not postfix, well, then we can turn P into, then P only consists of the star, and we can make P anything that we want to, including the whole string of S. So we return true. Now, if not prefix, what do we do then? Well, if the postfix is now inside of our string S, then it's automatically a match, right? Postfix in S. Same the other way around. If we don't have the postfix, then we just search for the prefix in S, and then it's true. Now, the most complicated case is when we have both a prefix and a postfix. So like in example 1, prefix would be EE and postfix would be E. So now we have to find an EE and then the single E. So how do we find the position of where a string occurs into another string? Well, in Python, we just use the find function and we just search for the prefix. And, right? And, well, for the end, I'll get prefix position, maybe call this postfix position. Well, if we do now find postfix, you could find E at the first position. So we want to do an R find. So that's basically finding from the right side. So this will give you the last position of the occurrence of the postfix inside the string S. Yeah, and now, well, we have to perform a little check. We would have to check return if the prefix position is well, actually, so we have to check whether it actually is in the index, right? So if we get if that is smaller than 0, that means we didn't find it. Same for the postfix position. You know, if it's not found, then the find function returns -1. So we have to perform the check. Now, if we find both of them, we just need to compare their position, right? And we need to make sure that there is no overlap, because if this was just lead, then this pattern would find a prefix and a postfix position. However, the prefix and the postfix position would overlap. So that's not good. So we have to check against that as well. So we check if prefix position plus the length of the prefix. Well, if that is smaller than the postfix position, then that's bad, right? So we can return this into, how do you say, into a very quick check. So I have to be careful with off by 1 errors now. So let's take the example of lead. And we say the prefix is EE, postfix is E. What do we get? So we have the position in is 0, 1, 2. So the prefix position would be 1, right? Prefix position. And the postfix position would be 2. So now I have to make sure that they don't overlap. So if I pick 1 plus the length of EE, that would be 3, right? And the position of RE is already 2. So I have to compare 2 versus 3. And this is so 1 too large. So what I have to do in the code is I have to add the length -1, and it has to be larger or equal. Yes. I think that's correct. So if we had, so if the postfix position is 2, that means 3 is larger than 2, so that's bad. However, if we had the string li, then our postfix position would be 3, and we have 3 versus 3, then we should return true. So we have to add an equals here, I think. I think that fixes the off by 1 error. Okay. Cool. Let's run it. So with that, I would say let's run it through the tests. Just the test cases here. See if we made any syntax errors or anything. But this seems to work just fine. So I think we've nailed the logic here. But to confirm fully, I would now run all of the tests by submitting this. And nice, and we pass off the test. Yeah, so this concludes this problem. And even though it was an easy one, you know, you have to, well, pay attention very closely to all of the edge cases. And yeah, hopefully you saw that going through easy problems is a useful exercise when you're practicing for interviews. It's not all about, you know, trying to solve the hardest problems. It's also about having a systematic approach and while going through that even when maybe you don't know what the answer looks like or anything. So yes, you can very easily get higher scores in interviews by just being systematic, implementing a simple solution rather than trying to be smart and implement the most efficient solution right away.